Assalamualaikum warahmatullahi wabarakatuh. My name is AFFAN bin SHUIB and my ID number is MH18056 and my other group mate which is SHARVIN, KENETH, YONG and RAZIQ, and we are from group 6 section 2 and we will present for lab 9 which is rolling disc on inclined plate for the course BMM2521 Engineering Mechanic Lab 2. So first of all, introduction. So the first one is free fall. Free fall is a good example of a consistently accelerated movement, and for the momentum, the behavior of all bodies is maintaining state rest or moving in a consistently straight path caused by a feature of the bodies known as inertia. Next, this is the objective of the experiment. The first one is determine the mass moment of inertia by rolling experiment, and then to find the downward force along an inclined plane acting on a roller due to the gravity. And the last one is determine the law of Pauling bodies on an inclined plane. And next, experiment setup. Actually, we change the new setup of experiment apparatus and assume as the TM611 rolling disc on inclined plane apparatus, which comprises of first one is 2 iron rods as an inclined plane, and then a board or the box to hold the iron rods as adjusted the angle of inclination, and then the protector. This is the protector to gauge the angle inclination, and then the ruler or the tape measure to gauge the distance, and then the two sides of ball, which is tennis ball and ping pong ball, to rolling on the roads, then flat surface, and we use the table to set up the experiment, and then the last one is stopwatch to measure the time taken. So this is we can see the rolling ball and the apparatus that we use in this experiment. So in the next slide, I will present about the experiment procedure. So the first one is to adjust the inclined plane inclination to the required angle by using the protector, whether either 1 degree to 7 degree. And then the second is select the appropriate distance between 0 meter and until 1000 millimeter, which is 1 meter, with the meter stick and measuring tape, and then set the stopwatch, and then we'll place the required ball, either the large ball and the small ball, which is a ping pong ball, for testing in the track 0 position. Ascertain that the rotating axis midpoint is at the marking and that the ball is in the center. And fourth, we will move the ball, or we can release the ball and begin the stopwatch, and then stop the watch and the ball when the ball reach the desired distance, and make that the watch is only stopped when the midpoint of the measuring mark has been reached. And then the last one is to reduce the measurement mistakes. We will repeat the measuring method numerous times, and then for each series of experiment, we will compute a mean value and record the result in table 1, 2, and 3. So that's all from me. Thank you.
Hello everyone. Good afternoon, doctor. My name is SHARVIN. Okay, today I am going to present about load time for a distance of 1000 millimeter lizard. Okay, for table 1. Okay, here is the lizard is to be calculator for angle of inclination, large disc and small disc. Okay, this result is about T1, T2, T3, T mean for large disc, and T1, T2, T3, T mean and small disc is to be calculated. Okay, for conclusion about this result, the angle of inclination 7 degree from small disc is more speed than compared to large disc. Okay, next one is table number 2 about large disc load time for a distance of 1000 millimeter. Okay, this result is about acceleration, calculated time, measured time, deviation is to be calculated. Okay, this result is about Yeah, these are for last slot time for distance of 1000 millimeter. As for acceleration at angle 7 degree is more speed than compared to the other angles between 1 degree and 6 degree. Okay, that's all. Thank you.
Assalamualaikum and very good morning. My name is AHMAD bin AZLI, metric card number MH1904. I'm going to explain about result and discussion. Okay, this is the table 3 small disc for the roll time for a distance of 1000 mm. If you can see here, we have do the experiment for the different angle, which is 1 to 7 degree. For the different angle, we get different acceleration, different calculated time, different measured time, and different deviation. Next, for the table 4, result for test 2. We got the different data for the large disc and small disc. We do the experiment 3 times. So we got T1, T2 and T3. Then we got the different data for the large disc and small disc. We calculate T mean by adding the T1, T2 and T3 and divide it by 3. We also calculate the omega, which is the radian per second, and the J, which is kilogram meter squared. Next, the discussion. First, how to adjust the angle of inclination. The angle of inclination can be modified by rotating the height adjusted spindle until the desired angle is achieved on the angulometer. However, we have found that sticking books or plates on one side of the inclined surface works best. Next, what is the purpose of angulometer? The angulometer purpose is to assess the angle of inclination, so we may set up our experiment within the parameters. Next, can you give an alternative method to measure the angle of inclination? We use the alternative method, which is we use the protector. This is because protector can be used to measure the angle of inclination as an alternate approach. Number 4, how to make a precise alignment for this experiment. We do the experiment on a level surface to avoid angle of inclination mistake. The angle of inclination can be measured with a protector. Then, why the angle higher than 7 degree cannot be used for this experiment? This is because when the angle of inclination is greater than 7 degree, the time needed by rolling this to reach the desired distance is just too short. As a result, measurement error will occur, and this will have an impact on the test final result. The last one is give the definition of free fall theory, which discovered by Galileo. A movement is said to be uniformly accelerated when it acquires at some point, starting from rest, identical intervals, identical speed increments. In close proximity to the Earth, a free-falling body accelerates uniformly, and air resistance is insignificant in comparison to the weight on the frame. That's all from me. Thank you.
Good day, everyone. My name is KENETH, and I'm going to present discussion part 2 and conclusion. So for number 7, the factor for that cause a free falling body is the surface area, angle, and the weight. And then the relation between the angle of inclination and the rolling disc is the rolling disc velocity is directly affected by the angle of inclination. The higher the angle, the faster the disc velocity. And then inertia is the property of an object to resist any change in state of motion or in rest, including change of its speed and direction. And then number 10, repeatability of measurement is important because we want to obtain the measured time and reduce error, especially human error. And then number 11 is the free body diagram of the disc roll. And this is the free body diagram and the force. And number 12, deviation occurs between calculated and measured value because, due to material qualities such as friction caused by the disparity between observed and calculated value. And then also caused by human error, we may mistakenly impart external force when we release the tape to roll, for example. And then suggest the improvement for the experiment is we make sure that the experiment surface is on a flat surface, and we have to prepare properly the experiment instrumentation to avoid bigger deviation. And then for conclusion, the time it takes for the disc to roll down the plank is determined by the disc weight due to Newton's second law of formula, which is acceleration equals to net force divided by mass, and then whether the mass is larger or lower. If the disc is heavy, it will accelerate slowly because based on Newton's first law, the Planck angle and Newton's second law can also be used to describe acceleration. And then the second law states that acceleration of an item is proportionally to its net force and act on it using the formula F equals ma. And then the force operating on our disk in the experiment was gravitational force. So when the inclined slope is steeper, the disk subjected to a bigger component of gravitational force, causing it to accelerate faster. That's all from me. Thank you very much.